Today I'll be discussing you about how to derive an expression to find out the radius of the nth orbit of an electron in the hydrogen atom. To start with, let us consider a nucleus. Let me write down the charge of the nucleus as number of protons present inside the nucleus multiplied by charge of one electron. And let us consider a circular orbit around the nucleus where an electron is in its orbit. Now, the distance between the nucleus and the electron is taken as small r. Now, we already know that any object or any particle which continues to stay in a circular orbit, it requires centripetal force. Now, the necessary centripetal force required for an electron to keep itself in its orbit is given by F is equal to m into v square by r. Remember, this force is the centripetal force required by an electron to keep itself in its orbit. Now, this centripetal force is provided by the Coulombic forces of attraction between the nucleus and the electron. Now, that Coulomb force of attraction is given by 1 over 4 pi epsilon naught Q1 into Q2. Q1 is the charge of the nucleus, Z times of E, into charge of an electron, another charge of electron, divided by the distance between the electron and the nucleus. It obeys inverse square law, therefore it is r square. Now, the necessary force, the necessary centripetal force required for an electron to keep itself in its orbit is provided by the Coulombic forces of attraction between the nucleus and electron. Let me consider this as equation 1. Let me consider this as equation 2. Now let us equate 1 and 2. Equating 1 and 2 will get us the relation mv square by r is equal to 1 over 4 pi epsilon naught into z into e square divided by r square. Now let us simplify r in this equation. So I get m into v square r is equal to z into e square divided by 4 pi epsilon. Now, we know that the second postulate of Bohr, which is also called the Bohr's quantization rule, it says the orbital angular momentum of an electron m into v into r, which is also taken as capital L, is an integral multiple of Planck's constant divided by 2 pi. Now, if I square this equation, now I get m square v square r square is equal to n square h square divided by 4 pi square. Let me consider this as equation 2. This is equation 3. Now, this one we will take it as equation 4. Now, equation 3 divided by equation 4 will get us m square v square r square divided by m v square r is equal to n square h square divided by 4 pi square multiplied by this expression z e square divided by 4 pi epsilon naught. Now, let us simplify this expression. M square get cancelled, v square get cancelled, r and square get cancelled, and again 4 pi and 4 and square get cancelled. Now what remains is, here we are left with m and r, which is equal to n square h square epsilon naught divided by pi z e square. Now the final expression is R is equal to n square h square epsilon naught divided by pi m z e square. So this is the expression to calculate the radius of an electron present in the nth orbit of Bohr's hydrogen atom. Suppose in this case the question is to calculate the radius of an electron which is present in the nth orbit of Bohr's hydrogen, then you have to take n is equal to 1 and you also have to take the value of z is equal to 1 because we are discussing about hydrogen. So this is the end of the derivation to calculate the radius of the nth orbit of an electron in the Bohr's hydrogen atom. Thank you.